Okay, let's dive straight in. We're looking at the hardware that lets you essentially build your own private cable company.
We are. It's the Thor Broadcast H-Petit-6CH-RM, and our mission today is to, cut through the specs.
And get to the core of it, how this thing takes multiple media feeds and turns them into a local cable system.
Exactly. It's all about high-power, centralized content delivery.
So at its heart, it's a rack-mountable chassis. Pretty standard stuff, but the flexibility seems to be the key here.
It is. This is the 6-channel model we're looking at, but the system is completely modular. It can scale from just 1 channel up to 12.
And each of those channels, these petites, they're basically their own independent encoders.
Yep, with their own loop out and NMS port for management.
So you can really see this in a place like a big sports bar, right?
Oh, absolutely. A sports bar, a corporate campus, anywhere you need to take, say, 4 or 6 different HDMI feeds and just blast them out to hundreds of screens at once.
Let's start at the beginning then. The inputs, it's HDMI.
It is. And crucially, it's HDCP compliant. That just saves you so many headaches with modern source devices.
So once the signal is in, what happens? What are we looking at for encoding?
The default for video is MPEG-2. For audio, you're typically looking at AC3, but you do have other options.
Like MPEG-1 Layer 2 or MPEG-2 AAC.
Exactly. That flexibility is usually about supporting older displays or, navigating licensing costs.
And what about the quality? The output resolution supports up to 1080p.
Yeah, and the video bitrate is solid. The spec sheet lists a fixed rate of 19.3 MEDPs, but you can configure it anywhere from 2 up to 24 megabits per second.
So that gives an operator a lot of control to balance pure quality against bandwidth.
Right, but I think the real trick here, the most impressive part, is how it gets that signal out over the coax.
The distribution power, it's huge. The RF output is rated at plus 24 dBmV.
That's a ton of power. I mean, that's strong enough to push HDTV video to hundreds of TVs without needing extra amplifiers.
So that's a massive operational saving. But is there a trade-off? I mean, does pushing that much power create heat or maintenance issues?
It's a worthy trade-off because the alternative is so much more expensive. The output is adjustable too, from 70 up to 100 dBs. You avoid installing mid-run amps, and that saves a fortune.
Okay, and this is where it gets really interesting for anyone deploying this globally. The modulation.
This is the aha moment. The RF output is completely agile. You can set it to pretty much any major CATV format you want.
So we're talking QAM and ATSC for North America.
Or DVB-T for Europe, ISDB-T for other regions. It just works. It's infrastructure agnostic.
And within those standards, you have even more control.
Right. Take QEM, for example. You can switch between 64 QAM and 256 QAM. Higher QAM gives you more channels, but the signal is a bit more fragile. It's a crucial dial to turn when you're dealing with long cable runs.
And this covers all the agile channels from 57 all the way up to 1,000 megahertz.
That's channels 2 to 145. It's got you covered.
So how do you manage all this complexity?
It's all done through a 10100 Ethernet NMS port. It uses a proprietary GUI.
Proprietary. That can sometimes be a sticking point, can't it? If a facility is already standardized on something open like SNMP, what's the learning curve like?
That's always the challenge with custom hardware, sure. But that custom GUI gives you really precise control over everything, especially that RF power level, which is critical.
So to sum it up, the H-Petit-6CH-RM is this really flexible, high-power tool for venues that need centralized control without ripping out all their existing cooking.
That's it. And if you connect the dots, that ability to switch modulation standards, it means this device isn't just for big installs, it's for installs anywhere in the world.
That leaves a really interesting question for you, the person who might actually be managing the system. Considering its modularity, scaling up to 12 channels, how might your choice of encoding standard affect the optimal number of channels you can reliably run at the same time?
A great question. Choosing a more robust, lower bitrate codec versus pushing pure 24 MEPs on every channel. That's a decision with real consequences for signal stability across your network.
Something to really think about when you're designing that system.